Question 3. So this is modelling with quadratics. We're talking about a stone. Good idea to make a picture of what's going on at the beginning. So it says this is about the height in meters. And the first thing I look at is the fact that I've got a constant here of 115. The other is multiplied by t. When the time is 0 seconds, that's going to be the moment at which the stone is thrown. So it's starting 115 meters above the ground level. So that would look something like that. And then it's being thrown and creating a parabola, something like that. And 0 will be the height of the ground. So what it's asking for with the physical interpretation of the meaning of the constant term 115 in the model is the cliff's height, or anything that kind of means that. Really, it could be the cliff's height plus the height of the person holding the stone, or it could just be the height of the stone at the moment above the ground at the moment at which it is thrown. But a good idea to put something about the cliff in there. But they always just want the cliff's height. They like to ignore the other bit. But yeah, anyway, any of those works. Write the function h in the form of this. So this has completed the square form. And the reason for doing that would be to find the turning point, which will be there. So it's going to be finding the maximum height of the stone when we do that. The first thing I would do is rearrange everything to be in. Rearrange it. I would not to be in that form yet. We can do that at the end. I would put it the way I'm used to seeing it. So with t squareds first, then with t's, and then the normal number. And I'm going to put a big square bracket around the terms involving t. And then because we've got a coefficient of t squared, we're actually going to take that outside the square bracket. So if we divide that by negative 4.9, we get positive t squared. If you divide 12.25 by 4.9, you get 5 over 2, or 2.5. Or actually negative, because it's a positive divided by a negative. And I'm actually just going to write that for now like that. Then you've got your 115 outside of it. Then let's do our completing the square stuff. So that stays the same outside. And we're doing a t minus half this number. So that would be 5 over 4 squared. Then we're going to have to take that square away. I like working with fractions here because it's so much faster. 5 squared is 25, 4 squared is 16, and then we've got our plus 115. Now always just try and do one bit at a time here, otherwise it's really easy to make a mistake. So that equals that, which equals that. So then if we remove the square bracket, in doing that, we need to multiply negative 4.9 by negative 25 over 16. And you can use your calculator to do that, obviously. And that gives us 392, plus 245 over 32 plus 115, and then rewrite that again. Take 4.9 t minus 5 over 4. At this point, maybe put that back into a decimal. 1.25 squared. When you add those two together, you get 3,925 over 32. And they don't mind how you show that, but at the end we need to put it in this form. So we've got the positive value first of all. So you might have it as that, or you might have it as the whole of the decimal number. Now when it gets to A level, if it doesn't say, you're meant to round things to 3 decimal places. In the mark scheme here, it actually said to allow that, which is the whole thing, to allow that, or to allow it 123, where it's been rounded to 3 significant figures, or anything really. As long as they can see you're working, they weren't actually bothered. Take 4.9 t minus 1.25 squared, and that's your full 3 marks there. Then, using your answer to part B or otherwise, find with justification the time taken after the stone is thrown for it to reach ground level. Well, I don't think we'd be using our part for part B to do that. I think you go back to the original function, because the ground level, if you look back at our thing, our ground level was 0. That was ground level. So we're looking for 0 equaling 115 plus 12.25t minus 4.9t squared. And then it's just a case of using the quadratic formula. So t is going to be equal to negative b, so that's negative 12.25, plus or minus the square root of 12.25 squared, take 4.4 times negative 4.9 times 115 all over 2 times negative 4.9. Now if you put that into your calculator, you get 2 different possible solutions. You get t equaling negative 3.75, I've just rounded that to 3 significant figures, or t being roughly equal to 6.25 seconds, and I'm crossing that one out because a negative amount of time isn't possible. What does that actually mean? The negative one would be if that parabola were to continue down to there and the stone had actually started its journey there and done the same thing, then that would be 3.75 seconds before it reached that point there. Right, and then the last part, the maximum height of the stone. Well, this is using what we did with completing the square, because the height of the stone is going to be our constant value there, because when this is equal to 0, that's going to be the biggest value we could have. So the max height is just going to equal 123 meters to 3 significant figures, and the time is going to equal 1.25 seconds, as that's the point at which the bracket's worth 0, and therefore we get our 123 meters.